Help nature heal itself. Lessons from beavers and beyond. What if the most sophisticated piece of machinery, capable of reversing decades of desertification and drought costs, less than a single bulldozer, and runs entirely on sticks and leaves? The answer is a flat-tailed rodent, the beaver. When we think of healing landscapes, we often picture heavy machinery, massive dams, or expensive restoration projects. Yet, time and again, nature has shown that with a little help, it can repair itself more effectively and more affordably than we ever imagined. The story of beaver reintroductions in the American West is perhaps the clearest example, but it is far from the only one. From salmon to forests, coral reefs to prairies, the lesson is the same. Sometimes the best solution is to let nature do what it has always done. Beavers, the ecosystem engineers. Few would have predicted that a rodent with buck teeth and a flat tail could succeed where human engineering failed. In the deserts of Idaho and Utah, rivers had shrunk to muddy ribbons. Aquifers were collapsing and habitats were turning to dust. Scientists and farmers tried stricter irrigation rules, more dams, even artificial water diversion, but the land remained parched. Then came a radical idea. What if thousands of beavers could do what concrete could not? At first it sounded absurd, beavers in the desert. But once released, the animals did what they have done for millennia. They built dams. They slowed water, spread it across floodplains, raised groundwater, and created ponds that caught sediment and nurtured new plants. Within months, frogs sang at dusk. Dragonflies hovered over new pools, and willows pushed up fresh shoots. Locals who had dismissed the plan stood stunned. One day, there was water where there hadn't been water for decades. The Methow and Yakima river basins in Washington told a similar story. There, dead land baked by drought, wildfire, and salmon collapse was revived by only a few hundred beavers. Within years, underground water tables rose. Salmon returned in droves, and wildfire impacts dropped by 40%. Studies confirmed that soil organic carbon increased by as much as 50%. Wetlands absorbed heat, and streams cooled enough for fish eggs to survive. The transformation was ecological, hydrological, and social. Farmers saw their wells recover, floods softened, and tourism ticked up as birders and photographers came to witness the rebirth. The cost? A few $1,000s per relocated beaver pair, dozens of times cheaper than artificial dams. And unlike concrete, beaver dams don't just sit in place. They grow, multiply, and adapt. Salmon, a species that restores its world. Beavers are not the only creatures capable of restoration. Salmon, too, are nature's engineers. Each year, when they return from the ocean to spawn in mountain streams, they carry vast amounts of marine nutrients inland, land, and as their bodies decay after spawning, they enrich the soil and waterways, providing food for fungi, insects, and plants. Eagles, bears, and wolves feast on them, scattering nutrient-rich remains across forests. Trees, fungi, and wildflowers absorb the nitrogen and phosphorus, becoming taller and healthier in salmon-fed valleys than in salmon-free ones. When salmon runs collapse, entire ecosystems suffer. Forests grow weaker, animal populations decline, and streams lose oxygen. Yet when salmon return, whether through dam removals or habitat recovery, ecosystems rebound with astonishing speed. In Washington state, after the removal of the Elwha River dams, salmon recolonized 70 miles of river within a few years. Sediment carried downstream rebuilt beaches, clams returned, and bald eagles began nesting again. By helping salmon return, humans unlocked a self-sustaining cycle that no amount of artificial fertilizer could replicate. Coral reefs and fish, protecting to restore. The same principle is evident in the sea. Overfishing and warming have devastated coral reefs, but some marine reserves show how quickly life rebounds if given protection. In Cabo Pulmo, Mexico, local fishers voluntarily stopped fishing. a 27-square-mile area in the 1990s. Within 2 decades, fish biomass increased by over 400%. Predatory species like groupers and sharks returned, and corals grew healthier as grazing fish kept algae in check. Tourists now flock to snorkel there, sustaining the community's economy. This is nature healing itself, not through artificial reefs or chemical treatments, but through time, protection, and the return of keystone species. Forests, the quiet regenerators. Forests, too, are masters of recovery, if we let them. In Costa Rica, abandoned cattle pastures once thought too degraded to recover have turned into thriving forests within decades, thanks to seed dispersal by bats, birds, and wind. Secondary forests now cover a quarter of the country, bringing back jaguars, monkeys, and countless insects. No heavy machinery was required, only patience and policies that gave land back to nature. Even in fire-scarred California, assisted natural regeneration is proving more effective than mass replanting. Rather than planting rows of seedlings, ecologists often fence off burned areas, allowing soil-stored seeds and surviving root systems to sprout. Native shrubs and trees return in mosaics that resist pests and drought better than uniform plantations. The land remembers how to heal if disturbance is reduced. The hidden helpers, microbes, and prairie roots. Not all restoration stories involve visible animals. Beneath our feet, soil microbes and prairie grasses quietly rebuild ecosystems. In the American Midwest, native tallgrass prairie once held some of the world's richest soils. Plowing and chemicals degraded them. But where prairies are restored, something remarkable happens. Roots several meters deep pump carbon into the soil. Fungi and bacteria knit it into humus, and water infiltration improves dramatically. Farmers practicing prairie strips, narrow plantings of native grasses within crop fields, report 90% reductions in sediment runoff and a surge in pollinators. Again, the key was not invention but invitation. Give native plants space, and they reassemble the community themselves. When nature outpaces technology. Some anecdotes border on the miraculous. In Canada, after a major oil spill near Little Buffalo in 2011, a natural beaver dam contained the leak before human crews even arrived. In Chesapeake Bay, beaver ponds filter out up to 45% of nitrogen, responsible for toxic algae blooms, outperforming multi-million-dollar wastewater plants. These are not isolated incidents. They are reminders that ecosystems have evolved sophisticated technologies, far older and more efficient than our own. Challenges and limits. Of course, letting nature heal itself is not always simple. Beavers flood fields and chew fruit trees. Salmon restoration requires removing dams that communities depend on. And coral reserves spark tensions with fishers who lose short-term income. Not every landscape can sustain wild engineers, and not every society is ready to adapt. Social and political hurdles are often as tough as ecological ones. Hydroelectric companies resist dam removals, farmers dependent on irrigation systems, fear disruption, and entrenched agricultural interests. Sometimes view low-tech ecological fixes as naive. Policy debates can stretch for decades, even when ecological results are clear. Yet even with these conflicts, the benefits often outweigh the costs. A rancher frustrated by beavers cutting his fence admitted, "They don't ask permission, they just build. But the gains are bigger than the problems." And in practice, tools like beaver deceivers pipes that control water levels at dams allow farmers to coexist with the rodents, while keeping fields from flooding. The lesson is not that humans should step back entirely, but that our role is often to facilitate rather than to dominate. Relocate the beavers, protect the fish, stop the logging, and then trust the system to do the rest. Policy in action. What facilitation looks like. If the theme of this article is collaboration, then the practical question is, What does helping nature heal itself mean in policy and action? Incentivizing coexistence. Ranchers and farmers who tolerate beavers or set aside prairie strips could be rewarded with tax breaks or subsidies. These small incentives encourage communities to see wildlife as partners rather than pests. Removing obstacles. Sometimes nature cannot heal until humans get out of the way. The removal of the Elwha River dams in Washington opened 70 miles of salmon habitat. Similarly, declaring marine protected areas gives fish stocks time to rebound. Investing in natural infrastructure. Governments can fund rewilding projects the way they fund highways, supporting wetlands that store floods, forests that regulate carbon, and reefs that buffer storms. These projects often pay for themselves many times over, compared to built infrastructure. In short, facilitation is not passive. It is a deliberate choice to trust natural systems, support them with policy, and manage conflicts with creativity rather than domination. A humbling vision. What ties these stories together, from desert rivers to salmon valleys, coral reefs to prairies, is humility. For centuries, we assumed that only human technology could fix ecological problems. We straightened rivers, drained wetlands, and planted monocultures, convinced that order was better than chaos. Yet the more we studied, the clearer it became. Ecosystems are self-healing networks. Remove the pressure, reintroduce the missing keystone, and life returns in ways we could never have engineered. As one hydrologist studying the beaver projects in Washington confessed, the beavers adapted far faster than we expected, and so did the desert. Nature does not need us to design every detail. It needs us to recognize when to step back, lend a hand, and allow the ancient processes of life to run their course.
It's time to study new words in context. 1. Sophisticated. Definition: something advanced, complex, or showing a high level of refinement. Example: the scientists developed a sophisticated system to track animal migration. 2. Desertification. Definition: the process by which fertile land becomes desert, usually due to drought, deforestation, or poor farming practices. Example: overgrazing has led to desertification in many parts of the world. 3. Flat-tailed. Definition: having a tail that is broad and flat in shape. Example: the flat-tailed beaver uses its tail to help it swim and build dams. 4. Rodent. Definition: a small mammal with strong front teeth for gnawing, such as a mouse, rat, or beaver. Example: the beaver is a large rodent, known for its impressive dam building skills. 5. Affordably. Definition: at a cost that is not too expensive and is within one's financial means. Example: the community built the water system affordably, without needing massive funding. 6. Ecosystem. Definition: a community of living organisms and their environment, interacting as a system. Example: the forest is an ecosystem where plants, animals, and soil work together in balance. 7. Buck teeth. Definition: front teeth that stick out, especially the upper front ones. Example: the beaver's buck teeth are perfect for cutting through wood. 8. Aquifer. Definition: an underground layer of rock or soil that holds water. Example: the town relies on a deep aquifer for its drinking water. 9. Parched. Definition: extremely dry, often because of a lack of rain. Example: the parched land cracked under the hot summer sun. 10. Floodplains. Definition: flat areas of land next to rivers that flood when the river overflows. Example: the floodplains provided rich soil for farming after each rainy season. 11. Sediment. Definition: small pieces of rock, sand, or soil that settle at the bottom of water. Example: the river carried sediment downstream and built new land over time. 12. Hovered. Definition: stayed in the air in one place without moving far. Example: the dragonfly hovered over the pond like a tiny helicopter. 13. Shoots. Definition: young stems or new growth from a plant. Example: after the rain, Green shoots appeared all over the hillside. 14. Water tables. Definition: the level underground below which the soil is saturated with water. Example: heavy rains raised the water table, filling nearby wells. 15. In droves. Definition: in large numbers or groups. Example: tourists came in droves to see the restored wetlands. 16. Hydrological. Definition: related to the movement and distribution of water on Earth. Example: the dam changed the hydrological patterns of the entire valley. 17. Tick up. Definition: to increase slightly or gradually. Example: bird populations began to tick up after the wetland was restored. 18. Spawn. Definition: to lay or produce eggs, especially by fish or amphibians. Example: salmon swim upstream to spawn in freshwater rivers. 19. Phosphorus. Definition: a chemical element essential for plant and animal life. Often found in fertilizers. Example: salmon carcasses add phosphorus to the soil, helping trees grow. 20. Self-sustaining. Definition: able to continue on its own without outside help. Example: the wetland became a self-sustaining ecosystem after beavers returned. 21. Replicate. Definition: to copy or reproduce something. Example: scientists tried to replicate the natural beaver dam using human-made structures. 22. Overfishing. Definition: catching too many fish so that their population becomes dangerously low. Example: overfishing nearly destroyed the coral reef's delicate balance. 23. Biomass. Definition: the total amount of living matter in a given area. Example: the biomass of fish in the marine reserve increased dramatically. 24. Predatory. Definition: describing animals that hunt and eat other animals. Example: sharks are predatory fish that help keep the ocean's ecosystem balanced. 25. Grouper. Definition: a large, heavy fish that lives in warm seas and is often caught for food. Example: groupers returned to the reef once the area became a protected zone. 26. Grazing. Definition: feeding on grass or other low plants. Example: grazing fish keep algae from covering the coral. 27. Algae. Definition: simple, plant-like organisms that grow in or near water. Example: too much algae can block sunlight from reaching underwater plants. 28. In check. Definition: under control or kept from growing too much. Example: the grazing fish kept the algae in check. 29. Keystone. Definition: something essential that holds other parts together. Example: beavers are a keystone species because many other species depend on them. 30. Seedling. Definition: a very young plant, especially one grown from a seed. Example: the seedlings grew quickly after the fire cleared the area. 31. Uniform plantations. Definition: large areas where only one kind of tree or crop is planted in the same way. Example: uniform plantations are more vulnerable to pests than natural forests. 32. Microbe. Definition: a very small living organism, often too small to see without a microscope. Example: microbes in the soil help break down organic matter. 33. Humus. Definition: dark, rich organic material in soil, made from decayed plants and animals. Example: the forest floor was covered with humus that nourished new growth. 34. Sediment runoff. Definition: sediment that is washed off the land into rivers and streams by rain. Example: planting grass reduced sediment runoff into the river. 35. Pollinator. Definition: an animal that carries pollen from one flower to another, helping plants reproduce. Example: bees are important pollinators for many crops. 36. Outpace. Definition: to move or develop faster than something else. Example: nature can sometimes outpace human technology in restoring balance. 37. Border. Definition: to be next to or along the edge of something. Example: the forest borders the river on both sides. 38. Hydroelectric. Definition: producing electricity by using flowing water to turn turbines. Example: The hydroelectric dam provides power to thousands of homes. 39. Entrenched. Definition: firmly established and difficult to change. Example: entrenched interests often resist environmental reforms. 40. Beaver deceivers. Definition: simple pipe systems used to control water levels in beaver ponds and prevent flooding. Example: the farmer installed beaver deceivers so the beavers could stay without flooding the fields. 41. Facilitate. Definition: to make a process easier or help something happen. Example: the new law will facilitate the restoration of natural wetlands. 42. Incentivizing. Definition: encouraging people to do something by offering rewards. Example: the government is incentivizing farmers to plant native trees. 43. Tax breaks. Definition: reductions in the amount of tax a person or business has to pay. Example: the company received tax breaks for investing in green energy. 44. Subsidies. Definition: money given by the government to support businesses or activities. Example: the farm received subsidies to plant more prairie grasses. 45. Rewilding. Definition: allowing land to return to its natural state and bringing back native species. Example: rewilding the valley helped restore its wildlife and rivers. 46. Monocultures. Definition: large areas where only one kind of crop or plant is grown. Example: monocultures are more easily damaged by pests or disease. 47. Hydrologist. Definition: a scientist who studies the movement and distribution of water on Earth. Example: the hydrologist analyzed how the beaver dams changed the river flow.
Comprehension questions. 1. What unusual method did scientists use to revive dying rivers in Idaho and Utah? Answer: they released thousands of beavers to build dams and restore water flow. 2. Why were people skeptical about reintroducing beavers into desert landscapes? Answer: many doubted that beavers could survive in such arid conditions, and farmers worried the dams would flood fields or disrupt irrigation. 3. What ecological changes occurred within months of the beavers' arrival? Answer: frogs and dragonflies returned. Willows sprouted, pools formed, and groundwater rose. 4. How did beaver reintroductions in Washington's Methow and Yakima basins affect salmon? Answer: beaver dams cooled the water, improved spawning conditions, and led to salmon returning in large numbers. 5. What was the estimated cost of relocating a beaver pair compared to artificial dams? Answer: about $2,000 to $3,000 per pair, which is dozens of times cheaper than building artificial dams. 6. How do salmon enrich inland ecosystems after spawning? Answer: as their bodies decay, nutrients like nitrogen and phosphorus fertilize forests, streams, and soils, supporting plants and wildlife. 7. What major ecological recovery followed the removal of the Elwha River dams in Washington? Answer: salmon recolonized 70 miles of river, beaches rebuilt with sediment, clams returned, and bald eagles began nesting again. 8. What happened in Cabo Pulmo, Mexico, when local fishers stopped fishing in a marine reserve? Answer: fish biomass increased by over 400%. Predatory fish returned, and corals grew healthier. 9. How have Costa Rica's abandoned cattle pastures shown natural recovery? Answer: they regenerated into thriving forests through natural seed dispersal, bringing back wildlife like jaguars and monkeys. 10. What role do prairie roots and soil microbes play in restoration? Answer: deep prairie roots pump carbon into the soil, while microbes create fertile humus, improving water infiltration and reducing erosion. 11. What surprising role did a beaver dam play during an oil spill in Canada? Answer: a natural beaver dam contained the oil leak near Little Buffalo before human crews arrived. 12. In Chesapeake Bay, how do beaver ponds outperform wastewater plants? Answer: they filter out up to 45% of nitrogen responsible for algae blooms, naturally cleaning the water. 13. What are some social and political hurdles in using nature-based restoration methods? Answer: hydroelectric companies resist dam removals. Farmers fear irrigation disruption, and entrenched agricultural interests often oppose low-tech ecological solutions. 14. What tool helps farmers coexist with beavers by preventing unwanted flooding? Answer: a beaver deceiver, which is a pipe system that regulates water levels at beaver dams. 15. What 3 policy actions can help humans facilitate nature's healing? Answer: 1. Incentivizing coexistence, e.g., subsidies for prairie strips or tolerating beavers. 2. Removing obstacles, e.g., dam removals, marine protected areas. 3. Investing in natural infrastructure, e.g., wetlands, forests, coral reefs.